Good morning and welcome to yet another webinar in the COVID-19 Inspire Hackathon webinar series. Today we are going to learn about Earth observations and how that can be used in predicting part of the food chain, and which is important for a COVID-19 situation. My name is Bente Liljaby. I'm going to be your host today, and as you can see, we have a panel of speakers, of experts that will teach you shortly. But before we go on with the program, we will do a usual weather report. And this is a sort of a tradition in the webinar series. And what I would like to know is what the weather is like where you are. And we will start and give you the report from inside this webinar room, but please let us know what the weather is like and where you are in the chat box. You see that we have the chat here. And in the chat, that's where we want your questions and comments later on in the webinar. But first, what's the weather like this morning? We can start with you, Herman. What is the weather like and where are you? You're muted, I think.
Sorry. Can you hear me?
Yes.
I'm in a village near Litomyšl. It's in the middle of Czechia, and the weather was, in the morning, it was 4 degrees, I think, but now it's a bit warmer, but we are expecting rain, but it's not raining now.
So far so good.
Just cold.
Yes. Okay. We are turning over to Ivo. What is the weather like and where are you?
Hello and good morning. I'm in Prague neighborhood of Žižkov, and the weather is cloudy. Maybe it's gonna be rainy again as well, as with Herman, but so far so good, and you can go out with your dog.
You can go out with your dog. Yeah, that's something. Okay, Karol.
Hi, my name is Karel. I am from Vinočany. It is very near from the Prague, so I think that there is not big difference in comparison with Ivo. Till now, we are allowed to left our houses, yes, but nobody know what will happen soon.
No, so benefit when it's not raining to leave your house in Czechia. That's the message today. Well, Wojtek, how about you?
Hello from Brno, Czech Republic. So we have a rainy. It's raining now. And also the temperature is quite low. It's about 7 degrees. So also the recommendation to stay in the room is good.
Okay, to stay in the room is okay down in Brno. Okay, so well, I will do a bit of a different report because I'm not in the Czech Republic. I'm in Norway, further up north in Europe. Very close to Oslo, the capital of Norway. And today we are expecting a very sunny day, but so far it's just fog. We can hardly see 100 meters. That's how dense the fog is. But it will be sunshine today, so I'm looking forward to that later on the day. So let us know what the weather is like where you are, and we can start with the program. I think, so you see we have 4 speakers here today, and they will introduce the challenge of using Earth observations in the food supply chain. You will learn something about some technologies that you can use, and you will also be introduced to the ESA BIC, and that's a place where you can get support for implementing your plans and making your Earth observation-based applications and services more operational. Okay, so I think we just dive in. I will ask you, the speakers, to introduce yourselves before you start the presentation. We can have questions. We can answer some of the questions in between each of the presentations. Don't be shy. Do ask questions and comment. And when we have a discussion phase at the end of the webinar, you will be able to raise your hand and get into the room and have a dialogue with the speakers as well. But there's a requirement there, and that is that you need to have a very good, stable internet connection. You need to have a Chrome browser, webcam, and mic. So and I think maybe the most important is that you have a very good internet connection. But with that requirement met, we will be able to invite you into the room. So just have that in mind. But please ask questions, and I'm sure all the speakers are happy to answer them the best they can. Okay, let's hear about this challenge. What exactly is it, Herman?
Well, can I start my presentation?
Yes.
Okay.
And introduce yourself first, by the way. Introduce yourself first.
Of course. Hello, I'm Herman. I come from Czechia. I work for LESS project, and I like everything connected with agricultural applications of remote sensing, and that's me. In my presentation, I will talk generally about the Challenge 11. It is Earth observation for monitoring of regional food supplies deviations. This presentation will be quite short, and it contains only 2 different topics. Firstly, I'll talk more abstractly about the goals of the challenge and possible ways to achieve them. And secondly, I'll present one example of what have been done at previous hackathons. Well, our final goal within this topic of this challenge is to be able to predict the yield during the season. In other words, it means we want to know the potential production of a field at any time. We already have some yield potential data. Now we want to verify if they are correct and improve the reliability. There is a lot of possibilities how to use yield potential information, and I will present you several goals and ways which we have chosen. The basic question is how to determine the yield from remote sensing data. Which bands or combination of bands to use, or which indices should we use? Because there are moisture indices, enhanced vegetation index, red edge, and all of these indices have possibilities to determine the potential yield. And the question even could be if there is one universal index for every crop, or if it is more precise to use different indices for different groups of crop. We have to start somewhere. That's why we have chosen enhanced vegetation index to determine yield potential, and we will test it on wheat during one season. We will calculate enhanced vegetation index for each pixel during spring season in 2018 on a field where wheat was planted. From it, we will get a number for every cloud-free days from Sentinel-2 2A image. And we need to compare these values. We use 2 ways to compare them. In the first way, we make a graph from enhanced vegetation index values, and from this graph we can calculate the integral. You see an example of the graph in the presentation. An integral is a number that represents area under the graph, and this makes one number for which will be assigned to the pixel, and we can compare areas where index was high and integral is also high, with areas where low index made integral small. And the second way how to compare index values is to choose some fields and make some statistical analysis within the field, like mean value and deviation. And the second part, the questions in the next stage are about impacts of issues during the season. How does relevant issue during growing season influence yield prediction? Did drought during last 2 weeks have a negative impact on yield or not? And how big is the impact? We will search how temperature affect yield potential. We can also use digital elevation model and inspect the role of insolation. And in the future, the dream is to deploy artificial intelligence and machine learning to the yield prediction process. And with the help of machine learning, we can make our prediction much more precise and quantify the impact of any meteorological issue. And finally, I would like to mention that the presented directions are not complete, and anybody can come with another application or improvement of the yield prediction. Another topic which worth mentioning is the soil moisture. Without doubts, soil moisture does influence yield. Therefore, it should have some influence on yield potential maps with which we are making. During previous hackathons, we have searched for the ways how to determine soil moisture using remote sensing. Some workflow using Sentinel-1 satellite was derived. You see it on the screen. And some experimental comparisons were done. However, again, in the current situation, we know that there is some relation, but quantification of the relation is subject of the future research. And soil moisture is a complex phenomenon. It is influenced by precipitation, temperature, sunshine, etc. So there is an idea to determine yield prediction using soil moisture. And yes, it is. You see how it could look like, the soil moisture map from Sentinel-1 data. And that's it. Thank you for your time. It's all from me, and I look forward for your questions and maybe future collaboration.
Indeed, very interesting challenges and interesting ways of using satellite data. Did you mention, I just have a question, did you mention that you will use other than satellite data? Do you plan to use some in situ data, ground-based data as well? Did you mention that? I don't remember.
Yeah, well, in situ data are not intended to use, but maybe you will hear from Wojtek that we use data from drones and other than Sentinel or satellite images.
And also crop rotation data, yes, from existing data.
Crop, what did you say? Crop?
Rotation.
Rotation?
Yes.
What is that, may I ask?
Wojta, maybe that you will explain the best.
You will explain the crop rotation, okay.
Crop rotation is the changing of the crops in time. It means that this year you have one crop and the second year you have another.
Ah, okay, yes. To change the use of the soil with different types of crop, okay. Yeah. Okay, so if you have questions to Herman about this challenge, some questions of clarification, just as I did now, please write it in the chat. If you don't have time to do it before we give the floor to Wojtek, we will be able to answer those questions later also. So please write in the chat, don't be shy. Wojtek, let's dive into more technical details here, I'm sure. So the floor is yours, but first and foremost, let us know a little bit about you.
Okay, so my name is Wojciech Lukas. I'm from Mendel University in Brno. It's in Czech Republic. I'm a postdoc at the one institution here, and my work is related to the precision agriculture or smart farming, and it's mainly focused on the mapping of the soil heterogeneity. So, and my presentation will be about how to identify the differences in the crop yields within the fields, and a little bit how to use it later for the farmers.
Can you put it in the presentation mode as well for us?
Yes, of course.
Yes. Thank you.
So I mentioned that the identification of the yield productivity zones is necessary for precision farming. And in this presentation, I would like to show you how we can use the Earth observation data, such as Landsat and Sentinel-2 imagery. So precision farming is a way of the farming where we can consider the natural spatial variability of the soil. So you can see that on the left side, it's conventional farming where the crop treatments are uniform across the fields. And on the right side, we try to identify the soil properties and to use the correct or right intensity of the crop treatment. In this case, it's potassium fertilizer. And to be able to make variable rate application of fertilizers or crop protection or different soil tillage or variable seeding, it's the most common operations in precision farming. So we need to get some input informations, and all informations need to be georeferenced. So we need some spatial data. And crop yield mapping is one of the most important. Usually, we get this data from the harvest. So the modern combine harvesters are equipped by the sensors, and we can estimate the crop yield differences from the yield maps. And
we lost your sound, Wojtek. That was strange. We still cannot hear you. Looks okay. Can you probably go out of the screen share and see if we can hear you when you come back? So, Wojtek, can you also come back to here now? Yes, now we can hear you again.
Okay, yeah. I'm sorry.
No, try it again and try to screen share and see what happens.
Okay.
Can still hear you. Yes, go ahead.
Good. So we have a lot of errors in this combine harvesters data. So as you can see, I'm sorry, it's in Czech only, but we have some obstacles within the fields, and these all errors need to be masked out. So it's the correct map is on the right side. Also, it's quite common if you have a bigger field, you have two harvesters on the field, and you need to merge these two data sets. And also, it's not so easy if these two combined harvesters have a different calibration. So there are some approaches how to do that, but it's quite difficult. And so we try to look for another solution, how to do that, how to identify the yield zones, and the best alternative is the Earth observation data. So in this case, on the left side, you can see aggregated maps of the yield levels from the harvesters, and on the right side, it's from in this case, Landsat data. And it seems to be very similar. So we are now working on this approach and to substitute the yield maps, crop yield maps from the harvest by the Earth observation data. For this, we are using two free available imagery from the Landsat and Sentinel-2. Both are multispectral, and of course, nowadays the Sentinel-2 has a better spatial resolution and temporal resolution, and also we have a better, or we have a more sensitive spectral bands in red edge. But we need to have some history of the data. Our approach is to look 8 years into the past, and in this case, we need to use also the Landsat data. So the methodology is that we use time series of imagery from 8 years as a combination of Landsat 8 and Sentinel-2 imagery. What needs to be good done is the cloud identification. So we need to be sure that each pixels which we are using in the analysis are cloud free. And Herman mentioned that we started with enhanced vegetation index. And also we are doing some selection within the vegetation period, as you can see on the right side, this graph. So we have a higher sensitivity in the June, May, and in the end of the May and first half of June for cereals. So this is about the Earth observation data, and also we need to know where the fields. So in Czech Republic, it's quite easy because we have open data about the field boundaries. So you can download it from the server of Ministry of Agriculture. But also we need some more specific data as crop rotation and some detailed changes in the boundaries, and this needs to be obtained from the farmers. And also we are facing the issues with the high occurrence of clouds in the imagery. This is example of last year, 2019, but also we can face it, and we can use the good imagery or some quite good scenes to do this calculation. And the result is called yield potential maps or production zones. It's quite a synonym of these two terms. And we try to compare it with the original harvester data. So as you can see on the right side is delineation of the production zones from the Landsat and Sentinel methodology. On the left side, there are crop yield maps from harvesters. This is from the harvest 2018. And as you can see, we found in the algorithms that there are some huge differences between the crops. So on the left field there was a wind rate, and it was quite good estimation of these zones. But on the right field there was oilseed rape, canola, and it was not so good because we were missing some better algorithm of the filtering of harvester data. So later we try to improve this filtering and improve the calculation. As the final product, we have three kind of maps. First is the production zones classified by 5% percentage scale. So it means that we are looking on the deviation from the field average. We are not able now to predict the yield at the absolute value, but we are able to show that there are zones with the expected yield plus 20% or minus 20%, and this could be later used for the farmers. Also, there is some simplification as a 5 zones map and 3 zones maps, which can be later very handily used by the farming practices. So here is one example, again, 2018, the farm Rostenice, which is a really big farm near to Brno with 10,000 hectares. And here is the estimation of the yield production zone. So this dark green, that means that we can expect higher yields that or above average yields. And this red or orange zones means that the yield is below the average for the field. And the same is showing the crop yield, are showing the crop yield maps from the harvesters from the year 2011, 18. And the same is in a relative values. It means we don't have absolute values here, but the relative, and we can compare the results. Also, we are doing the correlation between the crop yields and earth observation data. And this is from 2017. And you can see, for example, the time shift of the crops, which has in this condition, in the Middle Europe condition, longer vegetation period, such soybean. And we need to improve the selection scene algorithm to follow these shifts. Also, we find out that there are huge differences between the fields. So this is a graph of the correlation analysis, correlation coefficient between the crop yields and the EVI index. And this is from 2019. And as you can see, so there are the fields where the correlation is really low, but also where the correlation is high. And it depends on the field area. So the bigger fields, in the bigger fields, we can expect that there is a higher heterogeneity of the soil condition, and also the crop yield will be will have a higher variability. And as the last point, with the cooperation with the LES project company, we updated the calculation of yield potential or yield production zones for whole Czech Republic. So now it's updated for 2020 season, and it's available on this web page. So you can look on each field in Czech Republic. And the main impulse for that was to show to the farmers if their fields are heterogeneous, and if they should start with precision farming methodology or approach in their crop management. So that's all from my side. Thank you for your attention, and if you have any question, just ask. Thank you.
Thank you so much, Wojtek. This is really interesting and a very good presentation of the subject, I have to say. Just coming back to why we are doing this in the context of the COVID-19 Inspire Hackathon, this precision farming will then give us more information on what to expect in terms of agriculture production, right? To food production. That's the motivation.
Yes.
Yes. And I have one more question also. So you see, when you showed several maps showing different productivity of the different parts of a field. So when you see there's a difference, what would be the actions to improve the quality of those parts of the field that is not so good?
In the first step, we try to improve the crop management there. It means that we try to push to the farmers that they will not use the uniform doses of the fertilizers or uniform doses of the crop protection, and just to consider that there is some spatial variability within the field and to adapt their practices to this situation. And I think that the next step is to really make a detailed look on the situation on the fields, and to try to improve the field conditions or soil conditions to decrease the soil variability. But it's a question, in some cases it's not possible. For example, here in South Moravia region, there are farmers facing the drought period situation, and if there is not water available in the soil, so there is not so many things to do. So it's just a question of first step to know about that and to try to adapt, and the second step is to improve this situation.
But Vojta, I think also that there are now two different approaches. Yes, one approach is to try to make equal production in the all field, but second is to increase production in good areas. Yes, now very often is preferable to put more fertilizer in strong areas and not put fertilizer into the weak areas, because you can put there as much as you can and it will have no influence. So this is strategy, and now it's also discussed such things, because it is discussed this greening, when you will leave the part of field out of the production, and there could be also the strategy to leave this weak part out of the production and to concentrate on this good part of the field.
Yes, of course, and also these maps can show you which part of the field is it shows the lower productivity and could be set aside. So it means to decrease the crop management there, or to change the crop type, and the farmers should be focused with the higher intensity on the more productivity areas within the fields. Yes.
Right. So you mentioned, I just wanted to pick that up. Actually, you can also experiment with different types of crops being more productive on certain fields. But then, of course, I assume you have to have not only one season with that, but several to be able to actually draw a conclusion. But anyways, this is precision farming. As I think you beautifully illustrated what precision farming is all about. So thank you. I don't see any more questions, so I think we just hurry on. And I think, Carol, it's your turn to introduce yourself also. Not that everybody knows. We cannot assume that everybody knows you, even we have seen you many times here. Yeah.
So my name is Karel Charvat. I'm working for Less Project Plan for All, but also wireless info. And sometimes people called me that I am a good father of this Inspire hackathons, but I think that I can be considered also as one from good father of Earth observation or remote sensing in Czech Republic, because I start to work in this field at 83. So I remember the start of thematic mapper, Spot, and this other satellite. And now I am again a little more back in this. I am also active in Open Geospatial Consortium, where I'm share of the group for agriculture. And today I will tell you very shortly about the technology which is available for this challenge, and also a little, but it was already done partly by Vojta, about the data. So we can offer this digital innovation hub where we have two parts. One is the part for developer, and it is cloud-based solution using OpenStack with operating system CentOS, and the key tool for developer is Jupyter Hub. So this is on the level of physical abstraction and application level, and of course it will be not enough to have Jupyter notebook, so we are able to offer for analysis different libraries which are implemented, Python, R, GDAL, but also is possible to test it artificial intelligence platform as TensorFlow or Keras for the development of different analysis. Vojta mentioned that this yield potential, and that we together make this publicly available, and you can see now that these data are integrated into this AgriHub, Foodie AgriHub, and it is open available, and very soon will be possible also to download this data or use this data as WMS for different application. It is prepared together with other challenges. I think it is challenge 3, which will make this data available, for example, for all users of QGIS. Here Vojta mentioned that we are working on Rostěnice. Vojta mentioned that it is one from the biggest farm in Czech Republic, and I think that it is one from the most modern farm in Czech Republic. They have 32 or 36 machines with autonomous driving. They are using a modern method, and I am telling that this is the farm of year 2030. You can see that there are available different data. Vojta mentioned LPIS data. We are able to integrate different satellite data, orthophoto, and other data. And if you would like also make visualization of your result, our platform is able also offer you 3-dimensional visualization. This is also other things. It was also partly mentioned by Herman that 3D has with soil big influence on movement of the water in the field, and water is the key factor for productivity. So there is also possibility to deal with this. It was very shortly from my side. Here is his contact on me. If you would like to see this data on AgriHub, which is in the Czech, here is address. There is also possibility, and we will integrate this data also on Plan for All Hub, which is in English. I think that generally it is all from my presentation. About any details we can discuss with you. If you would like to cooperate or test it some tools, we can discuss this, and these tools are now available for the testing. And also I would like to mention that we are now finishing the huge European project UXDAT, and this develop also big e-infrastructure for agriculture, and now this infrastructure is moved to our cloud. So together with this AgriHub DIG will be possible to use this all UXDAT infrastructure, and we plan to make this now open for research.
Thank you so much, Karol. May I ask you to write those email address and web pages also in the chat so that people can easily click on it? and get
Okay.
access. I also want to add, when you mentioned all these resources, we just had the last summit of the Next.geo's Data Hub and platform. And in fact, you can also find a lot of the Sentinel data on the data catalog in Next.geos, including an access point. So if you want to search for data, agricultural data, Sentinel data, you can find that also on the Data Hub, the Next.geos Data Hub. You can also find the Plan for All data there. So go and explore if you are interested in having different ways of finding the data of your interest, and just get an overview. Do you have any questions to this? Please let us know. Don't be shy.
Hanka was faster than I was, yes? So.
Yes, she's super fast. So Anna Kubikova is one of our colleagues in the Plan for All. So I think we move on. If I don't see any questions here, Ivo, you get the framework now to introduce another opportunity that you have in ESA BIC. So you will give a short introduction to what that is, right? And we have some videos to show for you also. So Ivo, let us know a little bit about you first, and then introduce us to ESA BIC in the Czech Republic.
So, hi, my name is Ivo Denmark. I'm a business development manager of ESA BIC Prague. And first of all, Bente, can I ask you for one of the videos, just the first one?
The first one? Okay, I will start.
Doesn't matter which one.
I will start with that one, and you can see an introduction. So here you go.
There are several million drones in Europe. The question is, how can we keep the airspace safe with 5 million unmanned aerial vehicles flying all over without their colliding with other air traffic users? What the drone market needs is an online electronic registration plate for drones that would create an easy communication network between drone pilots, drones, and air traffic authorities. A group from the Czech Technical University came up with such a device. They call it Drone Tag. And it is a full package, a device, cloud platform, and a mobile app, all in one. The device receives GNSS navigation signal and then sends its position and identification data to the cloud platform. The platform communicates with authorities such as air navigation services and other drone pilots. And the drone is visible on the map for everybody in real time. Drones are no longer used just for taking cute beach pictures for your summer vacation. More and more often, they're employed in various industries, for agricultural planning or for high-voltage power line inspections, etc. This also adds to their growing numbers in the airspace. Drone Tag not only helps make the situation safer, but also opens the door for the future. The management platform and thus the overall coordination brings many possibilities, as unlimited flight and attachment of peripherals. So in the future, drones can be used to transport vital loads such as blood samples or organs. The pilot wants to fly his drone. He opens up the Drone Tag mobile app and simply draws his flight plan. The app then shares this information with the authorities. The request can be approved automatically or by the authorities. The new European regulation requires that almost all drones be registered and that they broadcast their position and identification data. The Drone Tag is ready to answer those needs and make the airspace more secure. Meet Drone Tag, one of the incubatees in the European Space Agency Business Incubator that brings space for your ideas.
And we are back. Yes, you are ready then?
Yeah, so I'll continue,
yes,
if I might. Can you see my presentation?
Yes.
Thank you. So what's ESA-BIC Prague? ESA-BIC Prague stands for European Space Agency Business Incubation Center, Prague. We are part of a European-wide network of ESA-BICs, as you can see on the map. Basically, what we do in a nutshell is that we take know-how from Czech aerospace companies and universities and innovators and students and whoever comes from the hackathons, and we try to make them into startups. How do we do this? So we basically let people to apply to our program, and then we introduce them to mentors. We introduce them to the business partners. We help them to develop their technology, and we give them funding to develop their technology and start their own business. Concretely, we offer in ESA-BIC Prague the incubation program that can last from 1 to 2 years, and then we have alumni period where we still work with our alumni, where we offer them workshops both on business and technology. We help them to find investors. We help them to find business partners, the technological partners. We help them to find office spaces and other shared facilities. And we basically introduce them to the network of startups that are both in Prague, Europe, and the whole Republic, the whole world. Why ESA-BIC? Sorry, wrong part. So the first question you might ask is why ESA is doing this and why it is important for us to basically introduce this. These business solutions. Is because it is important for ESA and both all the member states to use the space technology in both business area and the technology area to improve the everyday life. So this is as brief as I can get because I don't want to take too much of your time. And now, Bente, if I can ask you to introduce another one of our startups, and then I will give you a floor for any possible questions that you might have.
Yes, indeed. You want me to show the second video?
Yes, please.
Yes, and here it comes.
The rocket goes up, and at a certain height, it loses its boosters. Where do they land? There are plenty of uncertainties in these calculations, and it can be greatly affected by small disturbances such as temperature fluctuations, wind directions, or pressure changes. Remember the infamous butterfly effect? A small change in one state of an input condition can result in large differences in a latter state. We call this kind of calculation the propagation of uncertainties. It sounds like fuel for a spaceship heading to infinity and beyond, but it is a real deal in the space industry. Space engineer Martin Kubitschek came up with an algorithm that can crunch all the data and uncertainties, analyze them, and give them the structure and clarity in the form of the probability model. The probability model can be further understood and reduced, which enables it to have better accuracy, overcome critical moments, and reduce the costs. Engineering processes, like a plane or car design development, face the same issues with uncertainty similar to booster landing. For example, how will the change of rear rail's diameter affect the car if the driver steps on the brake while driving 60 kilometers per hour? How about at 150 kilometers per hour? For calculations like this, Kubitschek's company Optimi developed a unique tool, an algorithm, and engineering probability data cruncher per se. Same as with the rocket ship, Optimi can crunch the numbers and give you a better answer than any supercomputer can. Quantification, solution, and reduction. Optimi answers the question of probabilistic engineering design. With mathematical modeling, it reduces risks and saves money. Meet Optimi, one of the incubatees in the European Space Agency Business Incubator that brings space for your ideas.
So, as you can see on the both examples of our startups, there is plenty of usage in the business areas and plenty of applications that you can find. The reason why we in ISABIC Prague decided to join Plan for All hackathon is that many of our startups are solving the problems of agriculture. They are using satellite information, Earth observation, or even drone technology, which is also connected to the space satellite navigation technology. So there are many applications. One of the most important reason why we even have these hackathons and why is to improve the everyday life. And there's no better way how to do that than starting your own startup and providing some cheaper, smarter, better solution that you can find. So just to show, if you are interested in anything regarding ISABIC Prague program or incubation, I'm putting the link for our program on our website in the chat. And in the end, I will show you just a few examples of the startups that we have in our program that are actually considering and using some space technology and Earth observation data in agriculture. Can you see the presentation?
Yes. Yes, we can.
Okay. So just for an example, there is one of our oldest and most successful alumni. That's a company called BigTerra. And BigTerra use Earth observation data to monitor the climate, farming condition, and they are actually specialized to provide this information in the developing countries where there is not so much local data, for example, as in Europe. And they can do this quite accurately with limited amount of groundwork, and they are providing much needed information to the local businesses that are helping to improve the agriculture. Another one, I'll just skip the non-agriculture ones. Another one that has an agriculture connection is a Czech-French company called Aligo. Aligo is basically Uber for drones. Aligo solves the problem with sharing and operational capacity for the owners of the vehicles, where, for example, if you have a field or you just from time to time need some drone imaging, but you don't use your drone for the 99% of the time that you own it, you can share it via this application Aligo, or you just can rent it. You just can order drone monitoring for the specific time in the specific quality, and Aligo will deliver this to you. So those are just two examples of our startups. Up until now, ISABIC Prague and ISABIC Brno have hosted more than 30 startups, and there are still 10 new startups and projects that we incubate each year. Okay, and that's all for this quick introduction. So thank you for your attention. And if you have any questions, I'm happy to answer.
Yeah, thank you so much for that inspiring outlook, Ivo. I think this challenge here is rather technical, I would say. But what you just described is a possibility to take whatever is developed in this challenge to the next step, and that there's actually somebody there who can support in. But a question then. So you are ISABIC Prague. You know that this community is international. It's a global community, in fact. How is that? Would an international group be able to get support from ISABIC Prague?
So ISABIC Prague is a local brand. We basically support the companies that will be established in Prague or Czech Republic in general. But it doesn't mean that the CEO or the team members need to be Czech of the origin. We are incubating up to this date. We have American Egyptian rocket space company. We have Indian Earth observation company that's solving problems of overfishing. We are incubating right now a Swiss engineering company that's developing a new jet engine. So all of our programs and all of our workshop mentorings are run in English. That's a condition from ISA. And I actually think that Prague is a great place to start your Earth observation or satellite navigation-based business because the Prague is home of GNSS Center, soon to be EUSPA or European Union Space Agency. So Prague is slowly becoming, or fastly becoming, the great place to start this kind of hardware or software business regarding this technology. So we are open to everybody, and if they have a good and feasible business plan, which we will help them to develop.
Yes, yeah. So the requirement is basically that you have some Czech partner and willing to establish something in the Czech Republic. And indeed, I totally support you that Czech and Prague, but not only Prague, but Czech is very forward-leaning when it comes to using Earth observations, and also, of course, with Plan for All being a global organization, but based in the Czech Republic. It's really one of the communities that are very open. It's all about open data sharing, open source, and helping finding solutions in a very how should I say, inclusive way, which is really important to find solutions. So very nice to have you here, Ivo, and hear about that part of the chain when you're developing something that will serve the society. Carol, do you want to add something or ask questions? Please ask questions. Thank you, Ivo, for the link there. Be ready to ask questions.
Yeah. I would like to add something. You heard today about some piece of solution for agriculture. As agriculture is very, very wide, and there is necessary to work on the integration. And also, if you look on our web pages, yes, COVID Inspire Hackathon is the part of some process running from 2016. We are competing, yes, but the competing is more for funny, as the goal of this hackathon is put people together. And in reality, if you will look on the challenges in this hackathon, there could be 4 challenges which are in some way very close to this, and which in some way on the end can cooperate. Tomorrow there will be webinar which is really very relevant to program today, because tomorrow webinar will be about the climatic data and agriculture, and I think that this is the mixture. I am sure that our colleagues probably will also demonstrate something on Rostěnice, because Rostěnice is very popular, so you are welcome to join also other, but there are also other challenges 3 and 5, which in some way can give technology support for the data which are developed in one challenge. So we will compete, but on the end, yes, it is to put people together, to collect the ideas, to protect the results from previous projects, because this was the reason why we start with Inspire Hackathon, was that we recognize that very often something after end of the project disappear, and we are trying to give a chance to stay live with these ideas. And if you will look on our hackathons, you can see that something is coming from many years. And for example, this challenge 5 was first time on Barcelona hackathon, then it disappeared, and now it is again live. So as I am telling, yes, Inspire Hackathon is not event, it is process.
Absolutely, Karol. And you mentioned a few other challenges that is linked to this one. And I by the way, you mentioned the webinar tomorrow. The next challenge will be presented tomorrow already at 2 o'clock Central European time. You have a description of that challenge in the chat now, so you can go and check it out. But otherwise, we recommend that you go and visit the website for the COVID-19 Inspire Hackathon and see if you find also other interesting areas, if this is too technical for you. But I think, yeah, I don't see any more. I don't see any questions, so people are really shy. Maybe they need to digest what you just presented. Do the other here, Herman, Wojtek, do you have any questions to each other and or additional information that you want to share?
Not from my person. Thank you.
Wojtek,
Maybe can I have a question to Wojtek? Well,
yes.
When you have a potential map, and when there is a 100% like yield potential, it's on the same place. Is it every year the same amount, or when there is, I mean, 1 year very high yield, and next year is like the 1 year there is yield, for example, I don't know, 10 tons on a hectare. Does this make like 100% for the next year? If you understand.
Yes, I understand. We are not able to get the absolute values of the yield, not yet. And also one of the reasons is because we don't have also in such a big farm like Rostěnice, we don't have enough data, because it was mentioned that there is a crop rotation and we need to compare the same crop, and it is not possible. We are in 1 year. Yeah. So if we speak about 100% zone, that means that we need to consider the actual crop status and actual weather conditions. So in this year, it could be 6 tons of winter wheat per hectare, but in year 2016, it could be 8 tons. So it's just relative value, and every time we need some expectation from the farmer side. It means they need to put their expected yields as their knowledge and experience can get this value. So that's some weak point of this methodology, and I think that in near future it should be more focused on the recognition or prediction of absolute yield values.
But Vojta, I think that also all this happened in some climatic changes, because you mentioned this year and 2016, but I think 17 or 18, which was extremely dry, the result was not very valid, yes, because this is other things what we have to follow is the climate, and in some cases some extreme climatic can influence yield, because this is done only could be 2 months before harvesting, yes, and of course what will happen in the last period is difficult to predict.
Yes, this is something what we need to face, and the question of the climate or weather condition during the vegetation period is really important, mainly in the situation that if you have a not so good weather condition for the crop grow, we can expect the higher yield differences within the field. So that means that in a good weather condition or good year, so the variability within the fields is decreasing. And also this is something what we need to consider within our calculations. If we take 8 years of as the main input period for this calculation, so we need to consider that.
Yes. Thank you very much.
Okay, so this is one more reason why to follow webinar tomorrow. Yes.
Yeah. This is so by all means, you will, if you attended here, you will be seeing the replay as well. If it was a lot to digest immediately, we will post all these webinar recordings on the planforall.eu webpage. So follow there. You follow us also on Twitter, Plan for All on Twitter, to get updates. We will alert you through that channel as well. So with that, thank you so much for joining us, and we hope to see you tomorrow. And I'm hoping you find this challenge here interesting, so that you can join this group. Where can they join this group? What's the easiest way for people to sign up for this, Karol?
There is registration on the Plan for All web pages, and you can select this challenge 11. But if you are interested about this problem, you can also you can participate in 3 challenges. Yes, so you can select also some challenge which are related to this. I mentioned with this aspect it could be on the data side. This tomorrow it is challenge 13, I think. Yes, tomorrow it is challenge 13. But if you would like to know more about the data which can help you share and publish this, it could be challenges 3 and 5.
Yes. So go to the webpage and find the COVID-19 Inspire Hackathon. There's a list of all the challenges, so you can get an overview there. So if you go there, you will find it.
And there is detailed description of every challenge. Please, if you will go to the page of the challenges, because we have too many challenges, they are on 2 pages. So go also on 2nd page, yes, because there is already 13 challenges, and it is not possible to have on 1 page.
Exactly. So I just posted a link in the chat here. So you see the list of all the challenges is there. So, and as Karol said, scroll down because there are so many of them. With that, I think we can close this webinar, and good luck with the challenge, all of you. Thank you so much for your excellent presentations and inspiring presentation of the challenges. See you the next time, tomorrow already, maybe. Bye-bye for now.
Okay, see you. Bye.
Bye.